Hello classmates, let's learn this lesson. Low-frequency electronic circuits, Chapter 5, Negative Feedback Amplifier. So, let's learn a way to determine whether it is positive or negative feedback. The method of this judgment. Specific circuit judges that it is positive and negative feedback. We usually use the instantaneous polarity method. Instantaneous polarity, when this is joined, we transmit signals along the circuit, then go back through the feedback loop and go back in such a loop. Then use this indicate at this point with a positive or negative. I gave it instantaneous voltage change. For example, positive means that the voltage increases instantaneously, so the other thing is negative. This means that the voltage at this point decreases instantaneously. This allows the signal to pass through the basic amplifier circuit. Then, back to the input through the feedback network, transient voltage change on this experienced port. So, with this instantaneous change in voltage, help us judge feedback signals. Is the net input signal weakened or enhanced? Then we can judge whether it is positive or negative feedback. Watch out! I want to emphasize one point. We are based on this. By basic amplifier circuit and then through the feedback loop, transient voltage changes and nodes. To judge the output port of this feedback network, whether the feedback signal weakens or enhances the net input signal. That is to say, when you are not at this instantaneous polarity node, last then on the node where the net input signal is connected. The instantaneous polarity of is positive. It is either positive feedback instantaneous polarity or a negative feedback. No, it isn't. That means instantaneous polarity helps us determine feedback. Feedback signal output by loop. Is the net input signal weakened or enhanced? If it is enhanced for the net input signal, that's a positive feedback. If this feedback returns a signal pair, net input signal is a weakening. It's negative feedback. This method is called instantaneous polarity. Let's take a look. So how do you judge the first polarity change? That is, first through the signal input end. Pass basic amplifier circuit through feedback pole, so on different poles. So his polarity is similar. Connections change one after another. First, an instantaneous input from the transistor base. Voltage instantaneous positive. So on this lunge section, his lunge. It also produces an instantaneous positive voltage change. That is, along the lunge, the base and the emitter have the same voltage change direction. Then the opposite. If there's an instantaneous voltage rise at base, there's then an instantaneous voltage drop at the pole electrode, because we just said this. There's a loss increase the base voltage. Because of the voltage difference between the base and emitter, it's approximately equal to transmission series voltage. The voltage transferred to this emitter will also be lost. What about the voltage on the opposite electrode? There's a drop. We remember this rule. So when the instantaneous polarity of the signal is judged, it passes through the emitter junction with instantaneous polarity unchanged. If the base is positive, then the emitter is also positive, then no emission junction. From base to collector, its instantaneous polarity is reversed, will be the opposite, the same thing. For the field effect too, from grid to source, its instantaneous polarity will not change. From grid to drain, transient polarity has an opposite change. That is, I give the grid an instantaneous positive voltage. Then an instantaneous positive voltage is generated at the source. But on the drain, it produces an instantaneous negative voltage. Instantaneous polarity is constant through a resistance. That is, I gave it an instantaneous positive on the grid. Then, instantaneous positive, this small voltage, will also be generated at pole. Give it an instantaneous positive on the grid, a reverse voltage change will occur at the drain. Conversely, negative produces a negative. Along the circuit, this instantaneous negative along the direction of signal propagation. Reach the grid of the second tube, the grid of the second tube, and of course, it's the same as the leg of the first tube. It remains instantaneous negative. An instantaneous negative on the grid, instantaneous negative on the grid of the second tube. So, on the second tube, the drain is the opposite of what is produced on the grid. So the drain on the second tube produces an instantaneous positive. So let's take a look at the feedback network. It's a voltage feedback. It's a voltage series feedback. The output port of the feedback network is a voltage value. We care about voltage at this point. It's the change in the voltage of the feedback point. So let's have a look. If it just has T2 tube, if the drain is an instantaneous positive signal, pass through this RF resistance, so the feedback comes back to this node. Its voltage is also instantaneous positive. So what we will tell you later is how to tell is whether positive or negative feedback is generated. Now we are only concerned with the analysis of this signal transmission using instantaneous polarity. It has a sign opposite from the grid to the drain. The resistance symbol will not change after this circuit. Then go through the second grid and through the second drain, and the symbol is reversed. So if it has negative, it becomes positive. Let's take a look. How to judge the instantaneous polarity method. The net input signal is relative to the input signal. Is it weaker or stronger? Let's see. We first found its feedback elements. Then, the feedback element that passes through the basic amplifier is RE. Through basic steam combined with feedback loop, it should have a loop like this. The base gives an instantaneous positive. Emitter should be instantaneous as well as instantaneous positive. So, because this is on the input side, it's a series feedback. So series feedback is a comparison of voltage. So this feedback comes back. Feedback system to this feedback signal. XF should be VF. We don't care about VF. This potential is positive. It is a positive feedback. If the point potential is negative, the negative feedback is not. We care about this potential. Effect of VF potential change on the net input signal. If the net input signal gets smaller, that is the negative feedback. If the net input signal becomes larger, basic amplifier net input signal is larger. It's a positive feedback. So let's look at this. The VF returned from the feedback is an instantaneous increase. It's an instantaneous positive. This instantaneous positive feedback signal, what is the effect on the net input signal of the basic amplifier? Its net input signal is VBE, and now, as the potential at point E increases, VBE is getting smaller. Right, because of this, VBE equals VI minus VF. Now the potential at point F rises, so the VI pay actually gets smaller. So it is the instantaneous polarity method that determines if our base is transient positive, then the voltage signal returned from this feedback is also instantaneous positive. Yes, the net input signal is getting smaller. So it suppresses or weakens the net input signal, right? You just had an instantaneous increase in the base potential. Now I feedback back to make. The net input signal VBE decreases this trend, so it's a negative feedback. That is, if I am a cascade feedback, what we are concerned about is the feedback signal coming back, effect of voltage on net input signal. If the net input signal VI apostrophe becomes smaller, it's a negative feedback. Otherwise, it is positive feedback. If my input is a parallel feedback, what I'm concerned about is the instantaneous polarity method, feedback signal from feedback network. If it's weakening the net input signal, is Li apostrophe increasing net input signal Li apostrophe to determine if it is positive feedback or negative. It also depends on whether the amplifier has feedback in DC pass, or there's a feedback in the communication pathway. We can divide it into DC feedback or AC feedback. So some components exist in both the DC paths. Feedback also exists in communication pathway. For example, the circuit shown in the figure, first we know by common sense both RF and RE are actually feedback elements. It's a feedback source and gets a feedback effect, but RE this resistance, it acts as a feedback in the case of DC. So what if it's in communication? This C short circuits the RE and the AC, so RF is a feedback that exists in both AC and DC. Both DC and AC feedback, and RE disappears in communication. It's just a DC feedback. Very simple DC path. Existing feedback is DC feedback. Communication path feedback is communication feedback. Well, let's have a look. Capacitance is open in DC path, so this R2 serves as a feedback. This voltage that I feedback in the form of voltage as a comparison with the voltage of the basic amplifier. So it's a voltage series. Instead, it's a DC feedback. What about communication? In case of communication, this R is grounded directly, so it doesn't work as a feedback. So R is a DC feedback, not an AC feedback. So this R2 and the capacitor in the figure below have changed their position. In DC case, R actually has no connection to the input port, cut off. So RDC is not feedback, but capacitance is short circuit in AC case. So feedback in communication. So the picture below is just an exchange of feedback. The figure above is just a DC feedback. So let's have a look. This small image on the right, it takes a lead directly from the output to the reverse input. So this is the case with DC. The same is true for communication. So it's AC and DC feedback. The same is true for communication feedback. Let's take a look again. Such an R5. R5 acts as a feedback, but in communication, it was short-circuited directly by C3. So it has feedback on DC, no feedback in case of communication. Feedback then has a definition, that is, if it is in multi-stage amplifier circuit, one level of internal feedback is what we call local feedback. Otherwise, it is called inter-level feedback. So say it is R4 between the first and the second amplifiers. Connect such an R4, so it's an inter-level feedback. So what about R3? R3 only acts as a feedback in the second stage amplifier. So R3 is a local feedback. R4 is an inter-level feedback. Okay, this is the end of this class. Thank you.